Welcome to this video demonstration on swept meshes using TD Direct. A swept mesh is a type of structured mesh where a mesh is extruded from a source to a destination across a region. If the source and destination are edges, then the mesh will be across a surface. If the source and destination are surfaces, then the mesh will be across a solid. I'll start with this solid shown here in TD Direct. This is a simple solid that could be part of any model. I will show a couple ways to mesh this. I have already created the default unstructured mesh, which is a good place to start to make sure there are no problems with the geometry. I will start by creating a swept mesh on one end of this solid. I'll take this upper edge and define it as a source using the local mesh control. I will then set the mesh control on this front surface to have two layers. Then I set the far edge to a destination. This will effectively take a series of evenly spaced nodes along the edge and extrude them into a surface mesh. I want to extrude that new surface mesh along the entire solid. To do that, I will again change the mesh controls of this surface and add Use as Source. Normally I would have done that when I set the number of layers. Then I will triple click on the solid and set the mesh controls to 40 layers. At the far end, I will set the face to a destination. I'll synchronize the files and cut that time from the video. As you can see, this made a swept mesh along the first face based on the global mesh size and the number of layers. That surface mesh was then swept across the solid. Compared to the previous mesh, you can see why we call this a structured or swept mesh. I'll return to TD Direct, and the first thing I will do is clear all the tags. This tag panel shows all the tags assigned to the geometry. It includes tags for the mesh and thermal tags such as domains, materials, and submodels. I'll clear them all from this document and start over to show another way to do a swept mesh. For this new mesh, I want to use another solid. I have a master assembly drawing, and in this drawing I have created a component with an external reference. That externally referenced component, for meshing, is the linked TD Direct file. I'll drag this solid into the external component, and it will appear in my working file. This is a great way to incrementally build up meshes of assemblies. I'm going to create a 2.5D mesh on the original component. A 2.5D mesh automatically does a single layer, and will also use the same node number on either side of the mesh. For radiation and contact purposes, it is 3D. However, when the conductance and capacitance file is sent to Cinda, it will effectively be a 2D object, which will save processing time. This is only helpful if no significant gradients are expected through the thickness, and that is often true for brackets or other thin objects. To create two swept meshes in contact, they should go source, destination, source, destination. I'll create a source condition on these bottom faces by double-clicking one and selecting them together. For the first solid, all I need to do is check the box for 2.5D. For the top, I need to select the surfaces the same way as the bottom with a double click and set them to destination. For the new component, I can use my center scroll wheel to select the correct face and set it to source. The new solid will get 6 layers. The top will be the final destination. Another synchronization will show what I've done. The global mesh control is set to matched, so you can see the imprint of the new component in the mesh of the original component. The new component has 6 layers, implying a significant gradient is expected through that solid. The original thin component is 2.5D, meaning it is a single layer and the node numbers are the same on the top and bottom at a given location. In summary, swept meshes sweep an edge or surface across a surface or solid to a similarly shaped destination. There are some other restrictions, and the user should review the manual. A 2.5D mesh will create a single layer and use identical node numbers on each side of the extrusion. This is useful for thin solids with no significant gradient through them, but where correct contact and placement is desired. Thank you for your time. If you need help, please visit our website and forum at crtech.com or email us at support@crtech.com.